In this video, we're going to learn how to simplify radical expressions using one of the many formulas that tell us how to do that. So this formula that we're going to use, it actually gets used in two different ways. If we take the nth root of a divided by b, we can rewrite this as the nth root of a divided by the nth root of b. And we want to make sure that b, of course, does not equal 0. We don't want to divide by 0. And then the nth root of a as well as the nth root of b are real numbers. So no imaginary numbers right now. So this equation here, it actually works two ways. If you start with something that looks like the left side and want to turn it into the right side, we do this when we want to simplify. When we want to simplify a radical expression. If we go the opposite direction, so we start with two radicals on top of each other and combine it so it's just one radical sign, we go that direction when we do division. So it's the same equation, it just gets used in two different ways depending on what the directions of the problem are. So make sure to read the directions for the problem, and when you see simplify, it means that generally the one radical sign, we cannot simplify this any further, so we need to use another tool so that we can simplify our problem. So for example, let's simplify the square root of 9/25. So if this were another type of fraction like 2/4 or 1/9 or something, we might be able to simplify the fraction a little bit further and then get an answer that doesn't have a radical sign. But right now we can see that 9 does not go into 25. So as far as we know, this is simplified as much as possible, but because we have this extra tool over here, we can try to simplify it even more. So I'm going to use the simplify direction and rewrite this as the square root of 9 divided by the square root of 25. And then I go to each part and try to take the square root. So the square root of 9 is 3, and then the square root of 25 is 5. So now we actually have a really nice answer of 3/5. Before, the square root of 9/25 as it was couldn't be simplified, but by using this rule, we can get down to a nice answer of 3/5. Now let's try a problem that has variables in it. And I'm going to up the ante right here, and I'm going to make this a cube root problem. We want to take the cube root of 81x to the 8th divided by 8y to the 15th. So if I tried to reduce this right now, if I tried to simplify it, 8 does not go into 81, so that can't be reduced. This is a variable x, this is y. They're not like terms, so those can't be reduced. So as it is, this can't be reduced. But let's use our equation up here and use two radicals and see if we can get this to be more simple. So 81x to the 8th, that goes into the first radical. And then the second radical sign, cube root of 8y to the 15th. All right, so now I'm going to try to simplify what's underneath each of these radical signs. The way to start off doing this is to take my number and then also my variables and put them in groups of 3, or try to get them into 3 groups, because the way that the radicals will reduce is if you take the cube root of something cubed, those cube roots and cubes cancel each other out. So I'm looking for something to the third power. So I know 81, well, that is 9 times 9. And let's factor even more. That's 3 times 3. This other guy is 3 times 3. So that means that 81 is, we have 1, 2, 3, 4 of these 3's. We have 3 cubed times an extra 3. So in all, we have 4 3's being multiplied. Now I intentionally grouped this as 3 and 1 because I want a power of 3 so that my cube root will cancel it out. So I will start rewriting my problem. So far I have 3 cubed times 3. Now let's work on the x to the 8th. So x to the 8th, so that's 8x's multiplied. All right, so let's see if we can put this into 3 groups or into groups of 3. Sometimes it's easier to think of one way or the other. Let's see, if I start with, how about 2 together? 2x's, 2x's, 2x's. Well, this is now, I have 3 groups, and then I have a 4th group here, but in a way it kind of acts like the 3 cubed times 3. I had something repeating 3 times, and then I had the extra stuff left over. I have an x squared. This is an x squared, x times x. This is an x squared, and this is an x squared, and then there's my extra x squared. So this x to the 8th power, I have x squared repeated 3 times, and then I have an extraneous x squared. Because I don't want to write it to the 4th power, I want perfect cubes, not perfect fourths. And I can tell that this is correct because 2 times 3 is 6. 6 plus 2, that makes 8, so the exponents work out. So let's go fix this numerator over here. I have x squared, that is cubed, times an extra x squared. And now we have the numerator taken care of. Let's go do the same thing with the denominator now. So give myself a little more room. Let's see, we have 8. 8 is factored into 4 times 2. 4 is 2 times 2. So this is nice. We have 2 repeated 3 times, so 2 cubed. I'm going to rewrite this in a different color up here. So 8 is 2 cubed. Now I have the variable y to the 15th power. So I could write out the y 15 times, but I'm going to do this a little bit differently. My goal is to write this as groups of 3. So I know that 15 is equal to 3 times 5. So 3 times 5 is another way of saying I have 3 groups of the number 5. Or I could say that there's 5 groups of the number 3, but I want to have groups of 3 for that cubic root. So this y to the 15th, because a power to a power means multiply, I have 3 times 5. I can rewrite y to the 15th as y to the 5th to the 3rd power, because 5 times 3 makes 15. And this has what I want. It has an exponent of 3. I could have done something similar to the 8 exponent up here. I could have said 2 goes into 8 how many times, or 3 goes into 8 how many times, and then write the excess. 3 goes into 8 twice, so hence the 2 and the 3, and then the excess. In this case, we had a nice number. 3 goes into 15 5 times. So I have y to the 5th 3 times. So under the radical sign, I will say y to the 5th raised to the 3rd power. Now we can reduce our fractions here. We can reduce our radicals by looking at the cubic root and the cubic power and know that they cancel each other out. So every time I get to see something to the 3rd power, I get to rewrite the base just once on the outside of my radical sign. So that means there's going to be 3 on the outside, an x squared on the outside, and then everything left over goes underneath the radical. I had an extra 3 left over and an x squared, so 3x squared goes underneath the radical. And then for the denominator, so 2 cube rooted, that gives me a 2. Y to the 5th cubed, cube rooted, that gives me y to the 5th. And now we're done. We have simplified everything under the radical for the numerator and denominator. I've checked 2 and 3 don't cancel at all. X cubed and y to the 5th, those don't cancel at all. And then I have whatever's left over underneath this radical sign. So I have simplified this problem.